Good morning. Myself Prabhakaran J, working as an assistant professor in ECE department at SNS College of Technology. In this lecture video, I am going to discuss about the topic name is sampling rate conversion by a rational factor I by D. From the subject name is digital signal processing. Let me see. In decimation and interpolation, the sampling rate conversion is achieved by in a integer factor. When sampling rate conversion is required by non-integer factor, it is possible to perform sampling rate conversion by a rational factor I by d. The sampling rate conversion by a factor I by d involves the following steps. First step is perform interpolation by a factor I. Second step is filter the output of interpolator using a low pass filter with bandwidth pi by I. And third step is the output of anti-imaging filter is passed through another low-pass filter to limit the band of the signal to pi by d. D means a decimeter. Finally, the signal band limited to pi by d is decimated by a factor d. The process of sampling rate conversion by a factor I by d is shown. In order to preserve the spectral characteristics of x of n, the interpolation has to be performed first and decimation has to be performed next. The two low-pass filters with bandwidth pi by I and pi by d can be combined to a single low-pass filter with a bandwidth minimum among pi by I, pi by d as shown here. Here you can see x of n interpolator, anti-imaging filter and anti-aliasing filter which is used to rectify the noise and decimeter, and finally we can get the y of m. Consider the sampling rate converter which performs sampling rate conversion by a factor I by d. Here the discrete time signal x of n is first upsampled by a integer factor I, then band limited using a low pass filter, and finally downsampled by a integer factor d. The input signal is represented as a x of n, and upsampled of input signal is represented as v of I, that is x of n by I, and band limited version of x of n minus I is represented as w of I, and decimated version of w of I is represented as w of di or y of m. Let x of capital X of e power j omega, capital V of e power j omega, capital W of e power j omega, and capital Y of e power j omega are spectrum of the signal x of n, and upsampled version of x of n, and band limiter version of V of I, and decimator version of W of I respectively. For interpolation by an integer factor I, the frequency spectrum of output signal of interpolator is given by the equation V into E of j omega by equal to capital X of e power j omega I. Impulse response of the low pass filter represented by h of I. Frequency response of low pass filter represented by h of e power j omega. The low pass filter is designed to have a cutoff frequency omega c, which is given by minimum among pi by I and pi by d. H of e power j omega equal to a for omega equal to 0 to cutoff frequency, and otherwise all values is 0, where omega c, that is cutoff frequency, equal to minimum of pi by I, pi by d. Therefore, the output spectrum of low-pass filter W of e power j omega can be written as h of e power j omega into V of e power j omega. We know we know V of e power j omega is nothing but the spectrum of V of e power j omega is nothing but the capital X of e power j omega I. Here apply this I into x e power j omega I equal for omega equal to 0 to omega c, other than this 0 value is 0. Therefore, for decimation by an integer factor d, the frequency spectrum of output signal of decimator is given by y of e power j omega equal to 1 by d summation k equal to 0 to d capital D minus 1 w of e power j omega minus 2 pi k by d. Okay. Since there is no aliasing in the output, the above equation can be evaluated for k equal to 0 alone. Therefore, y of e power j omega equal to 1 divided by d w e power j omega divided by d. Therefore, equal to I by d capital X of e power j omega I by d omega equal to 0 to omega suffix y. Other than this value is 0, where omega y equal to pi d by I comma pi. The above equation is the spectrum of sampling rate convert by rational factor I by d. Okay. If you have any doubt, you can ask me through the comment. We will meet in next video. Thank you.